Hey guys, in this lesson we would understand the reciprocal of the quadratic functions. When we have the reciprocal of the quadratic function, then also we get a rational function that looks like fx equal to 1 over x squared minus 4. If we take x squared minus 4 as a quadratic example, here also we have the similar two ways that we have discussed in the previous lesson. We will first quickly discuss the way 1. Now the parent function that we are given is x squared minus 4. So its reciprocal function would be fx equal to 1 over x squared minus 4. We'll first use this equation to turn it into a graph. This is our vertex form of equation. We know vertex form is y equal to ax minus h squared plus k. H is 0. K is minus 4. So if this is minus 4, this is our vertex. We also know our x-intercepts would be minus 2 and plus 2 because the equation is y equal to x squared minus 4. We put y equal to 0 and solve for x, and that would give us x is equal to plus minus 2. So if this is minus 2 and this is plus 2, these are our x-intercepts. We connect these 3 points, x-intercepts and the y-intercept, to get our graph of parabola. Now the characteristics that we have to use to reciprocate and find out the graph of the reciprocal function are as follows. So first is x-intercept. We have plus minus 2. Y-intercept is negative 4. Positive interval is where the graph is positive or over x-axis. We notice everywhere from negative infinity to negative 2, this graph is over x-axis. So this part is positive, this part is positive, and this part of the graph is negative. So from negative 2 to positive 2, the graph is under x-axis. Before negative 2, the graph is over x-axis. And after positive 2, also the graph is over x-axis. So these two sections are positive and this section is negative. Therefore, positive interval is negative infinity to negative 2 and positive 2 to positive infinity, and negative interval is negative 2 to positive 2. Next is increasing and decreasing interval. For increasing interval, we would see where is the graph going up, and we see the graph is going up from here to positive infinity. For intervals, we always read the x value, so here the x value is 0. Therefore, from 0 to positive infinity, this graph is going all the way up, and from negative infinity to 0, this graph is always going down. We are always checking from left to right. So from negative infinity to 0, it's going down. From 0 to positive infinity, it's going up. Therefore, increasing interval is 0 to positive infinity, and decreasing interval is negative infinity to 0. We'll use these 3 important characteristics to find the characteristics of the reciprocal function. Because the x-intercept is plus minus 2, therefore the vertical asymptote is going to be plus minus 2. Y-intercept is negative 4, so y-intercept here would be negative 1 over 4. The reasons for all this have been covered up in the previous lesson, that is lesson number 8. So positive and negative interval stays the same for reciprocal and the original function. Therefore here also we would have positive interval from negative infinity to negative 2 and positive 2 to positive infinity, whereas we would see negative interval from negative 2 to positive 2. Increasing interval becomes decreasing interval. So in the reciprocal function, increasing would be negative infinity to 0 and decreasing would be from the increasing part, that is 0 to positive infinity. We'll use all of this information to make the graph the reciprocal function now. Also, because the numerator degree is less than denominator degree, so in this case also the horizontal asymptote would be y equal to 0. We'll put all of this information on the grid now. The horizontal asymptote is y equal to 0. That is on the x-axis. Vertical asymptote is plus minus 2. That means we have 2 vertical asymptotes as we have 2 x-intercepts. One is at negative 2 and one is at positive 2. So we get the vertical asymptotes. Next is y-intercept is negative 1 over 4. Let's say here is negative 1 over 4. Positive interval is negative infinity to negative 2 and positive 2 to positive infinity. So negative infinity to negative 2 means this section of the graph is positive, and positive 2 to positive infinity, and this section of the graph is also positive. So the left side of the first vertical asymptote and right side of the second vertical asymptote would see a positive graph. Negative graph would be from -2 to +2. -2 to +2, we would see a negative graph. Next thing is increasing interval will be from -∞ to 0. Therefore, from -∞ till here, this is the 0 mark, we would always see increasing interval. So this section of the graph is positive and increasing, as well as this section of the graph is negative and increasing. Decreasing interval is 0 to +∞. Now from 0 to +∞, the graph is decreasing. Therefore, from 0 to +2, the graph is negative and decreasing, and after 2, that is 2 to +∞, graph is positive and decreasing as well. Now how do we show this type of graph? Positive and increasing means it's going this way. These graphs are always symmetrical. This is positive, means above x-axis, and decreasing means it's gonna go downwards like this. This section is negative and increasing, so it also has to hit the y-intercept. So it is going to stay under the x-axis. However, it's going to keep increasing up till here, and after that we notice that this is going to be decreasing again, so it would start coming down but stay negative itself, and this is how the graph is going to look like. Always remember here one thing, that if we see a minima in the parent or the original function, we would see a maxima. That would be a local maxima in its reciprocal function. This is how we get the graph of a reciprocal function from the original function. Second way or second method of making the graph is also similar to what we have learned in the previous lesson when we did reciprocal of linear functions. We can try making the graph of the same function where fx is 1 over x squared minus 4. So step 1 was to find out the horizontal asymptote, because the numerator degree is less than denominator degree. Horizontal asymptote is y equal to 0. Second step is vertical asymptote. We always put denominator equal to 0 and solve for x. For vertical asymptote, so -4 moves on the other side to give us 4. X is equal to square root 4, which is plus minus 2. Therefore, the vertical asymptotes are plus minus 2 here. Third is y-intercept. To find out y-intercept, we'll put x 0, and that would give us -1 over 4. We'll mark these 3 points first. Horizontal asymptote is on the x-axis. Vertical asymptote is at -2 and +2. Y-intercept is -1 over 4. Now, fourth step in this case is end behavior near horizontal asymptote. We know horizontal asymptote has two ends. One is -∞ and one is +∞. So we would make two table of values. One we take is -10, other we take is -100. Here we take +10. +100. To solve for the table of values, all we have to do is just find out f of -10, then f of -100. The function that we have to work on is fx is equal to 1 over x squared minus 4. This gives us 0.01. Next is 1 over -100 square minus 4. This gives us 0.0001. Here we solve for f of 10 and we get 1 over 10 square minus 4, which will give us the same value when we put it on the calculator, 0.01, and f of 100 also would give us the same value as f of -100, that's 0.0001. So using these points, we would notice that when we approach the horizontal asymptote towards the end of it, the value becomes really small positive. From 0.01, it has gone down to 0.001 on the positive side. That means it is approaching the horizontal asymptote from top. However, it is going smaller, so it's going down. And here also it's going down, so it's going to be drawn like this because we're approaching from the positive side. So here also it's above the x-axis. Step number 5 we have is end behavior near vertical asymptote. Now this step is a little bit different from the end behavior near vertical asymptote in reciprocal of linear functions. The only difference here is because of two vertical asymptotes, we have to make 4 tables of values. So 2 tables would be approaching -2 from left and the right side, and 2 tables for approaching positive 2 from left and the right side. Therefore, for step number 5, end behavior near vertical asymptote, we would have 4 tables. First table, x is approaching negative 2 from the left side, that is from this side. So we put a small negative on top. Second table is x approaching negative 2 from the right side, that is from this side. Third table is x approaches positive 2 from the left side. And fourth is x approaches positive 2 from the right side, that is from this side. When we are approaching negative 2 from the left side, we are just going to take the x values on the left side of negative 2. One is distant from negative 2 and one is close to negative 2. So distant we can take is negative 10. Close we can take is negative 2.1. When we are approaching negative 2 from the right side, distant we can take is 0. Close we can take is negative 1.9. Now when we are approaching positive 2 from the left side, we can take a 0 as a distant value and 1.9 positive as a close left value to positive 2. On the right side, distant value will be positive 10, close value would be 2.1. We have already worked out for negative 10 and the positive 10 x values on the function, so we'll write on those values from step 4 table. Negative 10 gives us 0.01, positive 10 also gives us 0.01. Let's solve for the rest of the x values. F of negative 2.1 would be 1 over negative 2.1 square minus 4. That gives us, when we put on the calculator, 2.44. We can put that here. Next, f of 0 gives us 1 over 0 minus 4, which is negative 1 over 4. So this would be negative 0.25. We can put that value here as well. F of 0 is negative 0.25. Next we have to solve for is f of negative 1.9. That gives us negative 1.9 square minus 4, which is equal to negative 2.56. Then we solve for f of positive 1.9. That would also give us the same value, that is negative 2.56. Next we solve for f of 2.1. That gives us 2.44. Now let's use these table of values to find out the end behaviors near vertical asymptote. When x is negative 10, let's say somewhat here, y is 0.01, so it's close to the horizontal asymptote. When x is negative 2.1, that's somewhat here. It's a bigger y value, so that means the graph is supposed to go up like this. Now when x is 0, y is negative 0.25 and that's here. When x is negative 1.9, that's somewhere here if we are. Y value is negative 2.56, which is going to be lower than negative 0.25. So that means the graph's end is going to look like this, near this vertical asymptote. Now when we are approaching positive 2 from the left side, at 0 we have negative 0.25, that's here. And when we approach 1.9, y value is negative 2.56, which is here. On the right side, that is positive 10, we have 0.01, so that's a lower y value. Then x is 2.1, y is 2.44, that's going to be higher than this. So that means the graph is supposed to go like this. After we have drawn the arrows, all we have to do is just connect the arrows, and this is how the graph of the reciprocal of quadratic function would look like using all these steps. Once we get the graph, we can write on the characteristics such as domain, range, increasing, decreasing interval, positive, negative interval, if we are asked to do so in the question.